Hi friends, welcome back. Till now we have seen two kinds of Fourier series. One is a trigonometric Fourier series, another one is a exponential Fourier series. Sorry, polar form of Fourier series. Now let's go with the next Fourier series, which is nothing but exponential Fourier series. Okay, exponential Fourier series. So x of t can be represented like this: summation n is equal to minus infinity to infinity Cn e power j n omega naught. So this is the way we can represent exponential Fourier series. Okay. Here I already told you exponential Fourier series can be used both for x of t is real, x of t may be real, or x of t may be complex signal. It can be applied both for real and complex signals. Okay. Now, what if x of t is real? Suppose x of t is real. Okay. So that's what the analysis where we are going for. So here Cn is usually represented like this. The how to find out the Cn is the 1 by t integration minus t to by 2 to plus t by 2, or integration over a period. Better we can write like that, integration over a period. That means upper limit minus lower limit is equal to t. X of t e power minus j omega t dt. This is the way we can calculate Cn. What if x of t is a real signal? If x of t is real signal, we are not talking about complex signal, we are talking about real signal, because we want to compare exponential Fourier series with a trigonometric Fourier series, and a trigonometric Fourier series is applicable only for real signals. So to compare this exponential Fourier series and a trigonometric Fourier series, we require common platform. That is nothing but x of t is a real signal. So if x of t is real, so what is Cn formula? Actually we have written Cn is equal to 1 by t integration over a period x of t e power minus j n omega naught t dt. This is the formula what we have to return. Then this can be expanded like this, because e power minus j theta can be written as cos theta minus j sin theta. So by using that Euler expansion, we can expand this integral into two parts. So 1 by t integration over a period x of t cos n omega naught t dt minus j 1 by t integration over a period x of t sin n omega naught t dt. This is the way we can write it. Now observe this. This integral we have seen already. Suppose if 2 is there, this integral represents simply the coefficient small a n. If 2 is there, this integral is representing small b n. So if 2 is not there, this is nothing but a n by 2 minus j b n by 2. So this is the relation between a n, b n and c n. Okay. So in simple we can write Cn is equal to a n minus j b n by 2. j b n by 2. So this is the relation you have to remember, Cn. Okay. Now let's see. If you observe carefully, n can take both negative values as well as positive values. That means we are having positive indexed Cn and negative indexed Cn. That means n value may be positive, n value may be negative. What if I take negative value? Suppose if n is minus n, then what will happen here if I replace n with minus n? So will it make any difference? No, because cos value theta and minus theta is same. Next, if I replace n with minus n, then this value will become plus. So from this I can say, what is C minus n? That means negative indexed n. C minus n is equal to, if n is replaced with minus n, it won't make any difference, so an by 2. If n is replaced with minus, so this is going to be plus, so an plus jbn by 2. So in short, we can say, if x of t is a real signal, Cn and C minus n having a relation which is C minus n is equal to Cn conjugate. Conjugate you can take on both sides. So this is what the relation between Cn and C minus n if x of t is real signal. If x of t is real signal. If x of t is real signal. For real signal only this condition is valid, otherwise it is not. So why I have taken n and minus n? Because n, if it is positive, this is a positive value indicating, and this value is indicating negative values. Okay, I hope you understood. So this is the relation between an, bn and cn. Now what if I want to calculate an from cn and c minus n? How we can calculate bn from cn and c minus n? Suppose let's say, if I add these two, Cn and C minus n, what will happen? So jbn and minus jbn get cancelled, an by 2, that is going to be an. So directly we can write an is equal to Cn plus C minus n. This is the relation an. Next, how we can calculate bn? Suppose if I take Cn minus C minus n, this value minus of this value, so that is going to be minus jbn. So if that j is going here, that is going to be plus j. So cbn is equal to c minus n, sorry, j cn minus c minus n. So this is the relation what we got. You may get doubt, sir, it may be minus j. Please check it out. It is going to be plus j only. I hope you understood. Okay, this is the relations. So if you know an and bn, you can calculate cn. If you know cn, you can calculate an and bn values also. Clear? Take them. Exhibit, in general, cn is complex. Cn is complex, and exhibit conjugate symmetry. And exhibit conjugate symmetry. In general, Cn is complex and exhibit conjugate symmetry, because Cn is equal to C minus n conjugate. So from this relation we have written Cn spectrum. Now we are having, I already told you, spectrum means we are having both magnitude spectrum and phase spectrum. So let's go with a magnitude spectrum. Magnitude spectrum means we have to take mod Cn versus n omega naught. I will write it here. Mod Cn versus n omega naught versus n omega naught. So this is what we have to examine. We already know what is Cn, that is an minus jbn by 2. If this is the case, what is mod Cn value? That is root of an square plus bn square by 2. Now let's say I already told you n is taking both positive as well as negative values in the complex Fourier series. Now exponential Fourier series, we are having c minus n also for negative frequencies. So it is nothing but an plus jbn by 2. Then what is mod c minus n? Mod c minus n is equal to root of an square plus bn square by 2. An square plus bn square by 2. Okay. Now if I observe carefully, mod cn and mod c minus n both are same. Mod cn is equal to mod c minus n. From this I can say, so if I say negative frequencies, how much is the amplitude is there? Positive frequencies also we are having the same amplitude. That means if I draw the spectrum, it looks exactly symmetry. That means whatever there is the positive frequencies, that will be there in the negative frequencies also. So I can conclude that the magnitude spectrum in Cn, that means in exponential Fourier series, magnitude spectrum is exhibiting even symmetry. So it is exhibiting even symmetry. Even symmetry. Clear. In the similar manner, suppose if I consider magnitude spectrum is over phase spectrum. Phase spectrum. In the phase spectrum, we have to take angle of Cn versus n omega naught. Angle of Cn versus n omega naught. So this is what we have to do. Now let's see. If I take positive frequencies, what is angle of Cn? Which is nothing but minus tan inverse bn by an. Suppose if I take negative frequencies, angle of c minus n, that is directly tan inverse bn by an. Bn by an. So if you observe carefully, angle of c minus n is equal to angle of Cn, and with a negative sign, because this and this one having a sign difference which is nothing but minus. Now if you see, whatever the phase for the positive frequencies, the same for the negative frequencies also, but with a negative sign. So what does that means? For positive frequencies, if you are having 90 degrees phase, then for negative frequencies you are having minus 90 degrees. So what kind of spectrum it is exhibiting actually? The symmetry what it is exhibiting is nothing but a odd symmetry. So in general we can say phase spectrum is odd. The nature is odd symmetry. Odd symmetry. Clear? If you observe carefully, mod Cn is equal to mod c minus n is equal to root of an square plus bn square by 2, which is exactly same as capital An by 2, because this root of an square plus bn square is nothing but an by 2. Next, phase of Cn is equal to minus phase of c minus n. So what is that? Both are nothing but minus tan inverse bn by an, which is nothing but phi n, So here if I draw Cn spectrum from an and phi n spectrum, that means polar form spectrum we already seen how to draw a polar form of Fourier series spectrum. So from that spectrum also we can draw Cn spectrum. Only the thing is Cn c minus n magnitude is the same as an by 2. That means an will be divided into two parts. One is placed at n omega naught, another one is placed at minus n omega naught. Next, phase phi n. So whatever the phase for Cn, which is same as phi n, that means, and c minus n having the phase is equal to, suppose if I take minus here, minus phi n, that means positive frequencies you are having some phase which is same as a polar form of Fourier series phase, and if you want the phase at for the negative values of frequencies, that is simply the negative value for that. Clear? So that's what it is. Suppose if I draw a spectrum, then you can understand these things in a more clear way. Okay. First take down this, then we will see one problem. What we already done. Suppose we have seen one problem where we have drawn the spectrum for polar form of Fourier series. So for that, if I draw the spectrum for CN spectrum, then you can understand what is the difference between them and how we can do that. Okay, take it. An example. For this signal, we have drawn the spectrum which is polar form of Fourier series spectrum, and it is exhibiting what kind of symmetry? Hidden. In that hidden, we are having odd plus half wave symmetry. Odd plus half wave symmetry. We are having A0 which is A by 2, AN 0, BN value 2A by N pi for odd values of N. For odd values of N. And we have seen what is AN. AN. What is AN actually? Root of AN square. So that is nothing but 2A by N pi for odd values of N. For odd values of N. And Bn, sorry, not An, yeah, phi n is equal to minus pi by 2. That is also we have seen. And A0, which is same as small a0, so that is also equal to A by 2. This is the information what we got earlier, polar form. In the similar manner, if I take Cn, that is An minus jbn by 2. So what is An? That is 0. 0 minus j, that is 2a by n pi by 2. So 2 get cancelled finally, minus j a by n pi for odd values of n. For odd values of n. Then what is C0? Never ever substitute C0 directly here. Suppose if it substitutes C0, then that is going to be a by 0, which is nothing but infinity, which is not a correct one. So what is C0 actually, which is same as A0 again. That is also A by 2. So for this, if I draw the spectrum, so polar form An versus n omega naught. An versus n omega naught. Next, phi n versus n omega naught. Okay. So here omega naught value is equal to, here omega naught value is equal to 2 pi by 2, that is pi. So at omega naught, at 3 omega naught, and so on. At omega naught, at 3 omega naught, and so on. Now let's see. At 0, we are having a by 2. And phase angle 0. At omega naught, 2a by pi. Here pi by 2 minus pi by 2 is the phase. At 3 omega naught, so n value 3, so 2a by 3 pi, 2a by 3 pi. And so on. Phase angle still minus pi by 2. This is what the polar form of Fourier series spectrum. Now I have to draw the Cn spectrum, how it is going to be. 0. So magnitude spectrum mod Cn, and phase spectrum, that is angle Cn. Zero, zero. Let's take pi, pi, and here we are taking minus n value also, so minus pi, minus pi, 3 pi, minus 3 pi, and so on, minus 3 pi, and so on. At these values we have to examine. 0, so we are having Cn value which is a by 2 only, a by 2. Phase angle 0, phase angle 0. At pi, that means n is equal to 1. If n is equal to 1, a by pi is nothing but the magnitude. So if you understood here, Cn, if n is equal to 1 minus j a by pi. So what is the magnitude here? A by pi only. So here at pi we are having magnitude is equal to a by pi. So at minus pi, that means n value minus 1. N value minus 1, then it is j a by pi. Still, what is the magnitude? So that is a by pi only. A by pi. Next, what is the phase? N is equal to 1 means minus j a by pi. Minus j means angle is equal to minus 90 degrees. Minus pi by 2. If n is equal to minus 1, if n is equal to minus 1, this is going to be plus j. Plus j means angle is equal to plus 90 degrees. So here it is. Plus pi by 2. Next, at 3 pi, what is the magnitude? So n is equal to 3. 3 pi means 3 omega naught. N is equal to 3. If n is equal to 3, a by 3 pi is the magnitude. A by 3 pi. A by 3 pi. Here also a by 3 pi. Here angle is equal to minus pi by 2. Here angle is equal to pi by 2. Pi by 2. So this is what the spectrum, and so on it will go. And so on in this direction. And so on. And so on. So observe polar form of Fourier series spectrum. Polar form of Fourier series spectrum, and this is the exponential Fourier series. Spectrum. Exponential Fourier series spectrum. So what did you observe? If you observe, both the things are same. Both the things are same. Why? See here, an at 0 a by 2. Cn at 0 is same as a by 2 magnitude. At omega naught 2a by pi. Divide this into two parts. Then it is going to be a by pi, a by pi. One is placed at omega naught, that means pi. Another one is placed at minus pi. Better we can write them pi 3 pi like that, so that no confusion. So I can say the magnitude is divided into two parts except at 0, and one is placed at omega naught, another one is placed at minus omega naught, means positive frequency and negative frequency. Whereas coming to the phase, if you observe carefully, positive frequency phase exactly same. Exactly same. The negative frequency is only the thing is negative of the positive frequencies. So positive frequencies we are having phase is equal to minus pi by 2 plus pi by 2, minus pi by 2 plus pi by 2 like that. So are you seeing the similarity here? So how to write spectrum from polar form of Fourier series? So only one thing we can do is magnitude is divided into two parts except at 0. One is placed at a positive frequency, another one is placed at negative frequency. Phase spectrum, if you coming to the phase spectrum, so the same phase spectrum is continued for positive frequencies, and the negative frequencies, the phase spectrum is the negative of the positive frequency phase spectrum. So whatever the phase spectrum for positive frequencies, we have to take the negative values for the in the negative frequencies. Is that clear? Okay, take it. And remember, this is a one-sided spectrum, means only for positive frequencies, and here we are having a two-sided spectrum, but both for positive frequencies as well as negative frequencies. Clear? Take it. Let's see question 14. X of t is equal to 2 plus cos 2 pi by 3 t plus 4 sin 5 pi by 3 t. Find the Fourier series coefficients. Find exponential Fourier series coefficients. Exponential Fourier series coefficients. Okay. What is the x of t representation in the exponential Fourier series? X of t is equal to summation n is equal to minus infinity to infinity Cn e power jn omega naught. So this is the exponential Fourier series representation. Now if I ask e power jn omega naught t, e power jn omega naught t, what is the coefficient for it? Cn. If I ask e power j3 omega naught t, e power j3 omega naught t, what is the coefficient for it? C3, because j3 omega naught t, in that n value is equal to 3, so C3. What if I ask e power minus j2 omega naught t, minus j2 omega naught t, here n value is equal to minus 2, so this is going to be C minus n, this is going to be C minus 2, C minus 2. Is that clear? So this is what we have to see. So let's see, can we write x of t in that form? If I could write in that form, I can easily say what are the Fourier series coefficients. So for that, let's say what I am going to use. I can write first of all, we have to see the frequency here is 2 pi by 3 and here 5 pi by 3. Let's call it is 2 pi by 3 and 5 pi by 3. So let's say this is omega 1, let's say this is omega 2. So is it a periodic function? Yes. If I take omega 1 by omega 2, that is going to give you a rational number. Then what is the omega naught value? That is GCF of omega 1 and omega 2. So that is nothing but GCF of numerators 2 pi 5 pi by LCM of denominator 3 3. So finally pi by 3. This is omega naught. Now I want to represent x of t in terms of omega naught. How we can do that? X of t is equal to 2 plus cos 2 pi by 3, that is nothing but 2 omega naught t plus 4 sin 5 omega naught t, 5 omega naught. This is the way we can write. Once we could write like this, then what is x of t is again can be written as 2. By using Euler expansion, I can expand this cos 2 omega naught t like this. E power j 2 omega naught t plus e power minus j 2 omega naught t by 2. Clear? Plus 4 e power j 5 omega naught t minus e power minus j 5 omega naught t by 2j by 2j. This is the way we can write it. So if I could write like this, if I expand it again, 2 plus 1 by 2 e power j 2 omega naught t plus 1 by 2 e power minus j 2 omega naught t plus 4 by 2j, 4 by 2j, that is nothing but 2 by j. 2 by j means minus 2j minus j2 e power j 5 omega naught t minus 4 by 2j, that is plus j2 e power minus j 5 omega naught t. So this is the way we can write. This is the way we can expand it. So by comparing these two expressions, what is this 2 indicates? C0. C0 is equal to 2. What is this 1 by 2 indicates? It is a coefficient of e power j 2 omega naught t. I told you e power j n omega naught t, if it is there, Cn is the coefficient. So if it is e power j 2 omega naught t, the coefficient is nothing but C2. 1 by 2. And here e power minus j 2 omega naught t, then the coefficient is nothing but C minus 2. Here e power j 5 omega naught t, which is nothing but minus j2. So C5 is equal to minus j2. E power minus j 5 omega naught t, that means C minus 5. C minus 5 is equal to j2. So these are the Fourier series coefficients what we are having. Clear? Take it. Properties of exponential Fourier series coefficients. Properties of exponential Fourier series coefficients. So these properties are very important because the same properties will be continued even in what we can say Fourier transform and Z-transform, Laplace transform, everywhere these properties will be continued. So be careful with these properties. Let's see one by one. First property, linearity. No need quite to give numbers. Linearity. What is linearity property saying that? Suppose if a signal x of t having Fourier series coefficient Cn, another signal y of t is having Fourier series coefficient let's say dn, then what is the Fourier series coefficient of x of t plus y of t? It is same as Cn plus dn. But you have to remember one thing here, both x of t and y of t must have the same period, then only this property can be applicable. So applicable, or we can say x of t and y of t must have same period or same frequency. So this is a must and should. Okay. Next property, time reversal property. Take down. There is not much to explain here, so you can take it running notes. Okay. So time reversal property is saying that if x of t having Fourier series coefficient Cn, then what is the Fourier series coefficient of x of minus t, which is C minus n. C minus n. This is the property. Next, time shifting property. which is very, very important. Time shifting property. What is time shifting property saying? That if x of t signal having Fourier series coefficient Cn, then x of t minus t naught having Fourier series coefficient Cn e power minus j n omega naught t naught. This is the one. Suppose if it is x of t plus t naught, then Cn e power j n omega naught t naught. So this is the property. Okay, take it. We will solve one problem based on this time shifting property now. Question number 15. Let x of t be a periodic signal with period capital T. With period capital T. And y of t is equal to x of t minus t naught plus x of t plus t naught. The Fourier series coefficient of y of t is dn, if dn is equal to 0 for odd values of n, then t0 can be, options t by 8, t by 4, t by 2, 2t. Which option is going to be correct? Which is based on time shifting property. What is time shifting property? So let's say first, let x of t is having Fourier series coefficient Cn. Let x of t is having Fourier series coefficient Cn. Then y of t, which is equal to x of t minus t naught plus x of t plus t naught. It is having Fourier series coefficient dn, he is saying. So the question is saying it is having Fourier series coefficient dn. So can you write what is dn in terms of Cn? By using the time shifting property, we can write this as Cn e power minus jn omega naught t naught plus Cn e power jn omega naught t naught. So this is the way we can write. So from this we can write, suppose if I take Cn common out and multiply with 2 Cn, this is going to be e power minus jn omega naught t naught plus e power jn omega naught t naught by 2. So that is going to be cos n omega naught t naught. Clear? So finally what we got? dn is equal to 2 Cn cos n omega naught t naught. This is what finally we got. And this is going to be 0 for odd values of n. That's what he said. 0 for odd values of n. Okay. So Cn cannot be 0, only this cos term will be 0. So cos term, when it is going to be 0? If it is odd multiple of pi by 2. So already n value is odd. If n value is odd, this omega naught t naught must be pi by 2. So omega naught t naught is equal to pi by 2. Then what is t naught? pi by 2 into omega naught. Omega naught we know that is 2 into 2 pi by t. So finally pi get cancelled, t by 4 is the answer. So t0 value is equal to t by 4. Clear? Take it down.